Hi everybody, we're back for math. And this is going to be such a fun activity. I wish that we actually had all of the cubes and things that we need, but you know what? We're going to make it work and it's still fun. It's a lot more fun than just plain old,
calculations.
Yeah, definitely. So, this comes from North Carolina Department of Public Instruction for 5th grade. Well, I guess it still works for us. We're in California and we adapt easily. We're good people. So, it says cut out a 10 by 10 square from your centimeter grid paper. From each corner of the square, cut out a 1 by 1 square. So, Mr. Schmidt, I have my paper here. Could we move to the grid paper? Okay, so it says, first of all, I'm going to come up here and you know what, guys? I just really feel like I need something pretty. I need something pretty today. Okay, so I'm going there.
Do you want to enlarge it so it'll be easier for you to draw?
I think I'm good.
I think we should enlarge it. We'll shrink it back again.
Enlarge. Oh my goodness, Mr. Schmidt.
That's the next one. Okay, here we go.
Okay, so I'm going to start up here, and I'm going to, I have all this paper, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now,
they said make a 10 by 10 grid.
Yes, a 10 by 10.
I would do that first.
And so then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to bring this one down. Ooh, hard to make my line straight. That's why Mr. Schmidt doesn't let me drive that much.
That is so not true. She has her own car. I have my own truck.
I know.
And let me tell you, when I want her to drive her car when we're going to the beach or something, she still makes me drive.
I know. Hey, what is a man for?
Oh.
That's right, Selena. Make them work for it.
Okay, so the next step, wait, let's go back up and look.
So
it says, from each corner of the square that we just made, cut out a 1 by 1 square. I just wanted to refer back to that.
Okay, so what we're doing is we're cutting out a 1 by 1 square in each corner.
That's how I would have done that too.
And so we're going to take these out. So they're cut out. Okay. Oops, a little bit more. Okay, so those are going to be cut out. So that way, because if we snip off those corners, then we can fold them up.
And you guys could actually do it. I mean, it's telling you. But the problem is they only gave you guys one grid.
Yeah, so if you want to do this, actually you're going to have your mom or dad make the copy the paper for you, or you could probably do it.
Yeah. Okay,
so what we're doing, and when we're folding up, we're going to fold up these edges here. Okay? And so...
Okay, but make sure they don't cut those off, because now that kind of looks like...
Yeah, no, we're not cutting these off. We're not cutting these off. We're folding them. Okay? Well, maybe we should have
Here, I'll fix it.
Yeah. Okay. Okay. Could you take that one out, too?
Which, the line? Okay.
Yeah. Okay, because I'm thinking that what we need to do
maybe a dotted line.
Yeah. Maybe something like this. Yeah. That would probably be better. So we're going to fold it right here. So this is what they're asking us to do. Yeah, it'd be super awesome if we could actually...
This is almost like making a base 10 flat.
Yeah.
Except we're cutting off the outside corners, so it's going to be smaller than that.
Yeah, so you can fold it.
But it'll be the thickness of it.
Okay, so what we've done is we have taken those corners and eliminated them. And now we can fold these up. And so the question is asking us... fold up each corner. Okay, use the centimeter cubes to measure the volume of your... So what they're saying is use centimeter cubes to determine how many
And I just want to add in case they don't know, because some of my kids might not. Guys, remember when we use base 10 blocks, the smallest ones are those little tiny cubes. And those are 1 centimeter by 1 centimeter.
Yeah, those
so they're really tiny.
Yeah, and most of the time they're the orange ones.
Yeah,
but
and we have yellow, orange, and we even have some that are just plain wood.
Wow, you're cool.
Well, it's from being a teacher a lot of years.
Yeah, my class, we only have orange ones. Yeah. So, what we're going to do is, well, what is this area in here? Because that's the question, is what is the area? So,
well, they want the whole volume of this shape.
Absolutely.
Once we fold up the sides.
Yes. Well, from right here, what is is it the volume or is it the area?
Well, they're asking us the volume, right?
To measure the volume of your box.
Yeah.
Okay.
Okay, fold up each flap and tape them together so you have an open box. Kind of like the bottom of a pizza box. Yeah. Then use centimeter cubes to measure the volume of your box.
Okay.
So really, all we're going to have to do is count how many cubes we can fit in there.
Exactly, because it's only going to be one high. Right. Okay, so we have, I'm going to use a different color to point out the difference here. So I'm going to go with this dark green. So I'm going to go, I have 1, 2, 3, 4, 5, 6, 7, and 8. 8 across. 1, 2, 3, 4, 5, 6, 7. 1, 2.
Did you make this the right size, Mrs. Schmidt?
7, 8. No, I miscounted.
Okay.
Woohoo!
I was thinking. So let's talk about that real quick. It was 10 across, right, guys? Yeah. It was 10 across and 10 up and down, and we cut off a corner on each side. So we cut off 2 corners. So we have 10 minus 2, which equals 8 in both directions.
So I want to point out right here. So we took off 1, so that's minus 1. We took off 1 right here, so that's minus 1. We took off 1 here, so that's minus 1. These are rows that we've gotten rid of because remember...
We folded them up.
Yes, exactly, because originally we were supposed to be doing 10 by 10. Well, we subtracted 1 here, we subtracted 1 here, 1 here, and 1 here. So across, we've taken off 2, haven't we? So that's why it's 8. And then this way, we took off 2.
That's what I said, right,
guys?
Yes.
So we ended up with 8 by 8. Okay?
On the bottom.
Yes.
And on the top.
Yeah.
Because, guys, remember, this is a 3-dimensional box we'd be making, but it says with the top not there, right?
Exactly. So it's 8 by 8, which means 64. And the height was 1, wasn't it?
Right.
So it still equals 64.
64 cubic centimeters, guys, because each little space was 1 cubic centimeter.
Okay, so the way that we write that is we say 64 centimeters cubed. Okay?
Yes.
We say 64 cubic centimeters.
And you guys
when we write it, we say centimeters
And
cubed.
you guys know this, when you're talking about motorcycle engines and you're talking about a 500cc motorcycle engine, that means it has a displacement of 500 cubic centimeters. That's what the CC stands for.
Yeah.
Okay. Ready for the next one?
Yeah.
So let's go up and see what they want us to do now. Okay. Part D. You want to read it?
Okay. So how would your volume change if you cut out 2 by 2 squares from each corner instead of 1 by 1? Okay.
How would your volume change if you start? Okay, so we won't. That's another question. So right now, instead of a one by one square,
we're doing a 2 by 2.
Let me scroll down.
Okay, I'm sorry.
It's okay. When she's holding the pen over the tablet, I can't scroll down. Okay, so you want to do that on the other paper?
Would you like to do that one?
Okay.
Okay.
So we're gonna start with a 10 by 10 again, right, guys? Okay. So let me see. I'm just gonna start up in the corner. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that right? Right there? Okay.
Sounds right.
And 10 down. 3, 4, 5, 6, 7, 8, 9, 10. 10 down. Okay. So I'll come down here. Now, if I were using a ruler, and if I were at home like you guys, I'd probably want to use a ruler on this. And, see? That's why I want to use a ruler. Okay, let me see if I can use a line. Okay. And I want to just cheat a little bit. Let me see, and scoot that over. Can I grab this? Yeah. Oh, let me use the mouse then and grab that and scoot it over. Too far. Oh, let me hold this down. There we go. And I need one that goes across. Let me see. Maybe it's easier if I just use the mouse. Let me see. And start here and go to here. Why is it? Okay, whatever, people. Let's go up a little. There we go. Hey, hey, hey. Okay, go up. And we need one down. You know what? I'm just going to copy that one and put it on the top. I don't see where it went. Okay, so I'll just make a new one. Okay, guys, I'll just draw it. It might be messy, though. And down, up and down. And now I have a 10 by 10 grid. Let me switch colors. I'm going to use red to get rid of some, well, red. Oh, close enough. All right, so they said cut out 2 by 2 squares instead. And they want to know how's the volume going to change if I do that. And yeah, I'll shade those out. I just want to draw my little cutouts first. And guys, that's why we made other copies for you, because we said, hey, there's not even enough room for them to do all this on one piece of paper. So I need to cut out that corner and that corner and that corner and that corner. And so let's look at, if I folded it now, I'd be folding along this line and that line. I can tell that the bottom is going to be a lot smaller now. I cut off 2 on each side, so that means I'm cutting off 4 in total. So I should have 6 by 6 here, and I do. So I have 36, but I have 2 layers here. When I fold these sides up, that's going to give me 2 layers. So now I have, make sure I don't go off the screen, 36, and let me just write it out, 6 by 6 by 2. Okay, and I have 6 by 6 because we had 10. We took 2 off of each side, so that left me with 6 in each direction, 6 by 6. And then we had 2 high. So now I have 6 times 6 times 2. Okay, well, there's 2 different ways you can do it. We can just double the 36, and that gives me 72 cubic centimeters. And the volume changed.
It did.
That is interesting. Isn't that That's interesting, huh?
Yeah.
Okay, awesome.
That's pretty cool. Yeah.
Using the, that's just funny, huh? Use
That is weird.
Yeah.
Yeah.
Use the same piece of paper and you can create a different volume. That's amazing.
Mm-hmm. You would have thought it would be the same, but it's not.
But they must have anticipated it would change, because they're asking us how would it change if we did that.
Mm-hmm.
Okay, how would your volume change if you started with a 20 by 20 square instead of a 10 by 10?
Mm-hmm.
Huh. Okay, so I'm guessing they would want us to cut off 1 again. Are we starting with the same directions that we did for this first one?
I would think so.
Okay, because they didn't really
clarify
clarify
And so you
that.
would have 18 by 18
Yeah.
times 1.
So we have 18 times 18, because the 1's not going to affect it.
Yeah. And then the next one would be 16 by 16 times 2.
Mm-hmm.
Yeah. Yeah. So that's different. I'm going to let you guys play with that one.
Yeah. Okay.
So I'll give you guys something to play with, because it is fun. So take a look at it.
Yeah,
so
guys.
Just think it through.
Let me
Pretty
see.
cheesy easy.
Do they have room? Okay, so let me see. Do they have room to do this again? Do they, or is it not big enough? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You guys can make this twice. If you start your
In a
square
corner.
up here, you could do the other one down here, and you guys can build these and compare them. It'd be awesome.
Mm-hmm.
Yeah. Maybe you guys have Legos or something you can stick in there and see which one holds the most Legos.
Yeah,
cool.
definitely.
Yeah.
Yeah. Print it out and make it work.
Yeah. Okay, ready?
Absolutely.
Next problem.
Okay, so we have a problem today. $3.92 times 5.
And I need to zoom back out because that's off the page.
Okay.
There we go.
So draw a picture, $3.92. That sounds like a box of cereal to me, Mr. Schmidt.
It does, right? 5 boxes of cereal.
Yeah, 5 boxes of cereal. High value right now.
That's a lot of the same cereal. Maybe they're all the same price.
But yeah, it could be different.
Can you imagine 5
brands.
boxes of the same cereal? That's a lot.
Yeah, but a brand might have several varieties of cereal. So
Well, sure
yeah,
they do. But they're not always the same price.
no, depends. Okay, so if we do solve the word, I'm not going to do this. You guys can figure out what you want.
I know, because I thought of a word problem.
Okay.
What if you went to the malt shop and bought a hamburger that cost $3.92, and you did that every weekday, Monday through Friday?
Yeah.
Aha! Word
Yes,
problem.
Absolutely. Super sweet. So if we have $3.92 and we multiply that by 5. Okay. And I'm sitting at a bit of an angle, so mine's a little crooked. So 5 times 2 is 10. I'm going to put down the 0, and I'm going to carry the 1. So now 5 times 9 is 45, plus 1 more is going to be 46. So I'm going to carry my 4. 5 times 3 is 15, plus 4 more is 19. Okay? And my decimal is right there, so I have 2 behind the decimal. So I'm going to come over, put it right there. I'm going to put my $sign. And so I have $19.60. So if I was buying 5 boxes of cereal for $3,
or 5 hamburgers,
or 5 hamburgers, which would be more tasty to me, it would be $19.60. Okay? So now we can go on down and think about another strategy. Now, Mr. Schmidt had a strategy yesterday.
Yeah.
Lattice.
The lattice method, yeah.
Yeah. So I think we could go ahead and set that up for you, but I don't think I want to do it. I think I want to let you guys work it. And if you watched yesterday's video, you can go back and look at it and see how he did it.
And I want to just mention, I always write the numbers first, because that way I know how many squares I need.
Yeah.
I always use that as a guideline for
Oh, absolutely.
Yeah. So you guys, when you do it, and leave space between your numbers, just like she did right there.
Yeah.
Because you want your squares to be pretty much equally sized.
Mm-hmm. And then run your lattice like this here.
To me, they look like kites with tails, and you want those tails to go below. You want them to keep going below. Mm-hmm. Because you're going to add things up down them. So yeah, we really want them to go down.
Okay, so we could go down. Mm-hmm. Okay.
That's where you'll be writing answers.
Okay. So we could start the first one. 5 times 5 is 25.
So that's
so
2
my
tens.
ones would go right here, and my tens would go up here. 25. I had 5 ones and 2 tens. Mm-hmm. Okay? And then I'm going to let you guys finish it up with 5 times 9.
Oh, and don't forget the $sign in front of it.
Exactly. Oh, I'm sorry. Of course. And so 5 times 9.
And guys, when you do this, just remember how many decimal places you have. That's the same.
Exactly. Remember.
You do the same thing.
Remember.
Calculate it and then check your decimals.
Yeah. And then you can write the word problem over there, whether it's a hamburger or something else. You guys can determine what you want to make.
And if you guys want more help doing the lattice way, which is, I love using that just to check. I like solving a problem 2 different ways so I can check to make sure I got the right answer.
Absolutely.
Just send us comments on Dojo or something and say, hey, I want to know more about how to do it the lattice way. And I will show you. I'll make a separate video just for that. Perfect. I swear I'm not just talking. Okay, let's go down.
Okay, so lesson 9, the last part of math, volume of prisms. Okay, so volume is the amount of space inside a 3-dimensional figure. To find the volume of a rectangular prism, you can use a formula. Find the volume of a rectangular prism. Use the formula. Volume equals length times width times height. So it's L times W times H. Where volume, V equals volume, L equals length, W equals width, and H equals height. So I like to think of volume if you guys have a swimming pool. Volume is the amount of water in that pool.
Or the first problem we did today, making the boxes, right?
Absolutely. Yeah. So think about that. Volume is the amount of space that is being taken up. Mm-hmm. Okay, so if we move on down here to the very first problem, it says find the volume. Mr. Schmidt, is there one that you would like to do?
Let me see. Well, you know what? That first one looks very familiar, although it's 1 unit longer
Kind of
or
looks
wider.
like one that we did yesterday, maybe.
Yeah. So, well, let's do the first one because it'll be pretty similar to what we worked on yesterday. It's
Okay.
just, it's got one measurement that's different.
Okay, so the length, I think that we're going to come here, and the length is 1, 2, 3, 4, 5, 6.
And you
And
guys,
I
I just want to mention, if you mess up or if you have a different opinion of what measurements the length, that's fine because all three measurements will be different measurements, or even if they're the same. We'll have three numbers that we're multiplying, and it doesn't really matter which order you do it. So
I would like to spend a little bit more time on that, Mr. Schmidt, because you are absolutely right. Because we really, it doesn't matter. Because what you are working with there, or you're working with three measurements. You're working with this, you're working with this, and you're working with this. And it's up to you. This could be length, this could be width, this could be height. It doesn't matter.
And the way it's sitting, I would call the vertical measurement, I would say, okay, that's the height. But the measurement that's facing us, that could be the width, or you could say it's the length because it's the longest side. It's
Exactly.
up to you.
It's up to you. But I think that the way they have them set up top, this one here is the length. So let's go ahead. I'm going to measure this as the length. I'm going to say that this is the width. It's the depth here. And this is going to be the height. Okay? All right. So length again was 1, 2, 3, 4, 5, 6. Okay? And the width, 1, 2, 3. And then the height was 1, 2. So it's 2. So we come down here and
let me scroll now so that we don't go off the page. Okay, there we go.
okay, so what we're going to do is we're going to look here and we're saying, well, the length was 6. The width we said was 3. And the height we said was 2. Okay. So now, what is the volume? So we need to multiply these three numbers.
And you can do it in any order.
You can.
Commutative property of multiplication.
Exactly. Now for me, what I'm looking at to be easy to me would be 3 times 2. So 3 times 2 is 6. And so I'm looking at 6 times 6 now. Because this here, 3 times 2 was 6. Okay. And then times 6. So 6 times 6 is 36. And I don't need to write anything else out because
they already have it
already
labeled.
have it there. 36 cubic units. Okay? So up here, you're going to do the same thing. Remember that what you're doing is you're measuring this times this times this.
And can I just show something?
You certainly can, Mr. Schmidt.
There's a way where you can make sure you don't forget anything. You can start on a corner here where you can see all the lines that extend from it. So we have this one, and we have this. Oops. Okay. We have this one, and then we have this one. So if you just look at this vertex right here and look at all the lines that run up to it, you want to know the length of each of those lines. So if you do it that way, you make sure you don't forget anything. And you don't add anything extra to it.
Very good. All right, Mr. Schmidt, I think that we have come to the end of our day.
Yes.
I think it was a great day, and I've enjoyed this day very much.
Yeah, and I'm going to miss you guys.
Awesome. Oh, yes. Okay,
but at
guys.
least this video gets to be put up before we even wake up.
Yeah.
Before they wake up.
Yeah, so
it'll be there as soon as you need it.
It's awesome. So anyway, guys, if you have any questions, please feel free to let us know. And have a good day.
What was that thing? Oh, yeah. I said, really, guys, if you need help on doing lattice math with multiple digits, we could have more digits over here. If you want a video about that, please somebody send us a message. So far, I don't think anybody has sent us a message like that. So if you do, we'll make a video just for you.
All right, guys. Have a great day.
See you tomorrow.
Bye.
Bye.